Hello, my name is Tianjie.
Hello, my name is Wei Xian, and we are so excited to share with you something about private browsing. So, private browsing is a privacy feature included in some web browsers to disable browsing history, web cache, cookies, or any other tracking feature. This allows one to browse the internet without storing local data that can later be retrieved. The browser will only forget the info and data on the device being used. The browser, it will not save a history of searches, and also it will not save information such as cookies or information entered in forms. Let's say you want to connect to Amazon.com. When you connect to a website, your computer is making a connection to another computer or server that hosts the website. Much like you need a sending address and receiving address, the computer needs to know Amazon.com IP address before it can connect, and websites need to see your IP so they know where to send the response.
When you're connected through someone else's network, such as a workplace, the network administrator may see the traffic. Likewise, a bit like the mail carrier, the Internet Service Provider or ISP needs to relay the connection request to the website you visit. For now, this means the ISP is able to read the sender and receiver as well. They may also hold on to or share that information. Some websites only allow for an unsecured connections, meaning the pages you visit may be seen by anyone in between you and the website you are connecting to, such as the Internet Service Provider or your network administrator. For example, the HTTP means that you are making an unsecure connections, but some websites allow you to make unsecure HTTPS connections. For example, the Amazon.com. The little lock icon in the address bar means that your connections to the website is secure with HTTPS, and the ISP can't monitor the content on the page that you are connecting to. This is awesome. However, they still can see that you are visiting the domain Amazon.com. HTTPS is like writing things on a postcard, whereas HTTPS is writing things in a letter. A quote from Eric Groski, an author at We Life Security, sum up perfectly.
Hi, I am Wenfu.
Hi, I am Abel, and today we would like to share with you about anonymized browsing, for example, the Tor network. In an onion network, messages are encapsulated in layers of encryption, just like it is in an onion, and hence the name. These encrypted data are transmitted through a series of network nodes called onion routers, where each node peels away a single layer of encryption and decrypts the outermost layer of encryption using a key which is unique to itself and known by no other routers. Due to this multi-layered encryption, each node will only know the node immediately before it and after it. In addition, only the first router will know the identity of the originator. All other nodes are unable to determine if the router before it is the originator or just another node. And when the encrypted messages reaches the last node in the circuit, it decrypts the final layer of encryption and the original message is revealed. The last node then does what the message requests, for example, going to Facebook or just modifying stuff on Wikipedia or YouTube. To send the message back to the originator, the same process is repeated except in reverse, where the message is encrypted in a multi-layered fashion and sent from the back to the front.
Having more nodes in between and thus a longer circuit can greatly improve security, as it is much harder to identify the first and last node of the circuit and get a picture of the whole circuit. However, with greater length, the message will need to travel a longer length. Keep in mind the nodes are based all over the world and the message will need to travel vast distance between them. Ideally, a balance between speed and security is maintained so that the default circuit length of most anonymous browsing network is fixed at 3 nodes. The Tor browser is an implementation of onion browsing. Today, it has over 7,000 routers as known as relays, which form its network serving over 2 million users daily. These routers are all sourced from volunteers instead of being provided by Tor itself.
Next, we would like to talk about the similarities between these two approaches.
When the request from the browser to some website, both will send and receive IP address to access the website. Both will not save the history of searches and information of such as cookies and information entered in forms.
Whereas, the differences between the two approaches are, when your PC requested the IP address of the website, it will go through the Tor network first. Tor will bounce your request to a few servers, or known as the relay nodes, and finally send it to the particular website before back to your PC. All of the users in the Tor network looks the same, which confuses the observers and makes you more anonymous. So, the more people use the Tor network, the stronger it gets, and it is more easier to hide in a crowd of people who look exactly the same. Initio browsers differ from Tor browsers in a way that it will direct send a request to the website and receive the address back to the user browser.
Privacy trade-off. Prior browsing prevents information from being automatically stored on a device such as browsing history or download cookies, but your online activity is still visible, safe, and could be shared or sold to third party. Next, performance trade-off. Incognito will always be slower than regular Chrome because when in incognito mode, the browser doesn't store cache. This means that each time you visit a page, the file, image, etc. all have to be re-downloaded from the web server, which makes site generally load a little slower.
The performance trade-off. Tor browser gives you access to Onion websites. They are only available within the Tor network. Many prominent web services block access to Tor. Sites that do not block Tor might push you to click through a ton of captchas. The privacy trade-off. Whenever you use Tor to access an encrypted website, the exit node can monitor your browsing patterns, pages you visit, messages you send, and searches you perform, and thus it isn't really safe.